Let's start with a question. Alright, so we see this kid and we assume he's going to throw this ball in his hand. But I want to ask, where will the ball land once he has thrown it? That's right, today in Solitary Space Science, we are going to be working with projectiles. So, yeah. Hopefully, we all know that things fall because of gravity, and that throwing the ball will put it into a forward motion. And using what we learned last week about force vectors, I think that we'd be able to answer this question of problem with just a little math. So let's go do that. Alright guys, so let's find out how far the ball, or where the ball is going to land in relation to the boy. So let's assume that we have the boy right here, okay? And he is throwing the ball. Right? Okay, let's say he has the ball in his hand. And let's assume that he's going to be... Why is this working? Okay. Let's assume that he's throwing the ball at a 45-degree angle. And let's also assume that that the ball will be traveling at 10 meters per second. Okay? So now, using what we learned in the last video and our basic trigonometry skills, we should be able to figure out. So the first thing we need to do is we're going to need to find how fast the ball is going to be traveling with respect to y, to the y direction, or j, or whatever, the y-axis. So how do we do that? Well, so on the triangle, we're basically going to be trying to find the side opposite to the angle. This is 45. Okay? And these two lines here just means magnitude. Okay? So this operation is going to involve the hypotenuse and the opposite. And we know from SOHCAHTOA that in order to find this here, we're going to use sine. So we're going to do sine of 45 is equal to the velocity of the ball with respect to y divided by 10 meters per second. Okay? And we also know that we can move this over there. So we have 10 meters per second sine of 45 is equal to the magnitude of the velocity of the ball. Okay? So now, if you can get out your calculator and solve this, you should get approximately 7.07 meters per second. And that's how fast the ball is going to be traveling on the y-axis. Okay? So, next, what we're going to try to do is we're going to try to find the velocity on the x-axis. Okay? So how do we do that? This operation, well, we could use the opposite over here, opposite over adjacent, but I think it'd be easier to do cosine. So let's do, so to find x, we should do cosine of 45 is equal to the magnitude of the velocity x sub x over 10 meters per second. And we're doing cosine because SOHCAHTOA tells us that we want to find cosine as adjacent or hypotenuse. So yeah. And again, you can move the 10 meters a second over here. So we have 10 meters per second cosine of 45. And sorry, this pen is a little blurry. I'm just trying to conserve space, or preserve space, not conserve. And if you were to solve this, you would realize that it is also 7.07, and I don't know, when I first saw this, I wasn't really thinking, and I thought, how could that be? But then, I looked at the angle again, and 45 is half of 90, which would be a right angle. So it's going to be moving the same amount along the y-axis as the x-axis. And it would be moving with a slope of 1. And you would go ahead and divide, a change in y, 7.07, divide by change of x, and you would get 1. So yeah, that's just some. Okay. And we're trying to find where the ball will land on the x-axis, right? We need to find a position, or a distance from the thrower. Okay? So how do we do that? We are going to find the change in time. How do we do that? We can take the velocity on the y-axis, and we can assume that that is equal to the acceleration due to gravity, because that is the force acting on the y multiplied by the change in time. And we want to figure out what the change in time is. So we're just going to divide both sides by acceleration g. Okay, and that would get us our change in t. So let's solve this. We have the 7.07. That is our velocity on the y-axis divided by 9.82 meters per second squared for the acceleration of gravity. And if you were to go ahead and solve this, you should get approximately 0.71959 for the change in t. So what do we do with the change in t? Now we take the change in t and we multiply it by the, so we take the change of t, we multiply it by the magnitude, or the velocity on the x-axis, and we should get the distance, or we should get displacement. That's what I'll do. So now let's just multiply 0.7199959 multiplied by 7.07 for the velocity on the x, and if you could get out your calculator and solve for that, you should get approximately 5.09. Okay, and that is going to be the total distance, or meters, from the original starting point, which would be the kid. Okay, this is going to be total displacement. Okay, now we have successfully answered the question at the beginning of the video. And yeah, so you are watching Solidarity. You're watching Solitary Science, and my name is Yuichi Greywright. And I just wanted to say one thing before we end this video. I think I'm gonna do more modern physics, like string theory and loop quantum gravity, and concurrently with these physics lessons, classical mechanics. So yeah. Again, this is Solitary Spade Science. My name is Yuichi Greywright, and I am signing off now.